Scientific notation. So for very large numbers and very small numbers, we have scientific notation. Let's start with a quick warm-up. You guys pause the video here and change each of these into standard notation. All right, welcome back. So 10 squared would be 100. 10 to the fourth would be 10,000. And 10 to the ninth would be 1 billion. So note that the exponent is the same as the number of zeros. So 10 squared, we had 2 zeros. 10 to the fourth, we had 4 zeros. And 10 to the ninth, we had 9 zeros. For small numbers, we have like 10 to the negative 3. Well, the law of negative exponents tells us that 10 to the negative 3 power would be 1 over 10 to the third, which is 1/1000th. Or as a decimal, 1/1000th. So a negative 3 for an exponent, we're moving the decimal 3 places. 10 to the negative 6, the law of negative exponents says that's 1 over 10 to the 6, or 1 over a million, 1/millionth, or 1/1,000,000th as a decimal. So the negative exponent tells us the number of places the decimal must be moved to the left. Numbers written in scientific notation look something like this. So if we look at these numbers in scientific notation, what kind of patterns do we see? Well, I see multiplication. I see numbers with decimals. I see powers of 10. I see everything being multiplied by 10 with an exponent of 10. These are indicators that we have scientific notation. We have a first number multiplied by a power of 10 with an exponent. And if I look a little bit more closely, I start to see a pattern with these first numbers. I have 5 and 2/10. I have 1 or 1.0, 3.215, and 9.99. All these numbers have something in common too. They're numbers between 1 and 10. So the first part is a number between 1 and 10. It can be as small as 1, but must be less than 10. In other words, there must be one and only one digit to the left of the decimal. So if there's only one digit to the left of the decimal, it would have to be a number between 1 and 10. And like we said, as small as 1, but less than 10. And the first part is going to be multiplied by the second part, which is always a power of 10 with an exponent. So to change a number into standard notation to a scientific notation, we're going to first move the decimal point so that the first number is between 1 and 10. So our first step is always going to be to get that first number to be between 1 and 10. So I want you guys to take these 4 numbers, write them down, and move the decimal to make them between 1 and 10, and then restart the video. So pause the video here. All right, welcome back. If we move the first one to make it a number between 1 and 10, we put the decimal between the 1 and 4. And the second number, to make it a number between 1 and 10, we would put the decimal right here after the 3. And 941, to make it a number between 1 and 10, we would put the decimal between the 9 and the 4. And our last one, 0.056, I want to get the decimal right here between the 5 and the 6 to make that a number between 1 and 10. So notice how all our numbers between 1 and 10 just have one digit to the left of the decimal, making it a number between 1 and 10. So that's the first part of scientific notation. Get that number between 1 and 10. And then our second part is to count the number of places we move the decimal. We count the number of places we move the decimal, that's going to give us the exponent for the power of 10. And if our original number is a very large number, we will have a positive exponent. And if our original number is a very small number, we will have a negative exponent. So remember, scientific notation is really only for really big numbers and really small numbers. And we'll be able to tell if it's a really big number or a really small number when we look at that original number to know what sign we're going to use on our power of 10. All right, so let's change some numbers into scientific notation. If we start with 2 million, first we're going to want to get the decimal to make it a number between 1 and 10. So I'd put the decimal right after the 2, which means I need to move 1, 2, 3, 4, 5, 6 places. So I'm going to have 2 times 10 to the 6th power. And since it's a very large number, I'm going to have a positive exponent, so I have positive 6. Now let's look at 42,600,000. Where are we going to put the decimal? Well, the decimal is going to go right here between the 4 and the 2, which means it originally starts here. So 1, 2, 3, 4, 5, 6, 7 places. So 4.26 times 10 to the 7th. All right, you guys try this one, change it to scientific notation, pause the video here, and come back and see how you did. All right, welcome back. Hopefully we got that decimal between the 3 and the 5, so 3.51 times 10 to the 5th. 5 places over to get it between the 3 and the 5. Also a large number, so we have a positive exponent. All right, we have our first really small number. We need to move the decimal 1, 2. So if we start here, 1, 2, 3, 4 places to get it behind the 3 to the right side of the 3. So I have 3, or 3.0 times 10 to the negative 4. So we have this really small number, so we're going to use a negative exponent. All right, you guys pause the video here and try to turn this one into scientific notation. All right, welcome back. So the decimal would need to go between the 8 and the 5. So we're going to need to move 1, 2, 3, 4, 5, 6, 7 times to get it between the 8 and the 5. So 8.52 times 10 to the negative 7. The other thing we could do is we could be given something in scientific notation and asked to be taken out of scientific notation and put it in what's called standard form or standard notation. So to put this into standard form or standard notation, we have 5 times 10 to the 4th. Well, that'd be like moving the decimal on the 5 over 4 times, or we could think of it as 5 times 10 to the 4th, which is 100,000. So 5 times 10,000 will give us 50,000. So probably easiest to think of it as a 5 with a decimal here and move 4 places to the right. How about 5 times negative 4? 5 times 10 to the negative 4th, we're going to move the decimal the other direction. We're going to move left. So we move left 4 places, 1 to get past the 5, 3 more zeros to get 0.0005. And I think that should help get you guys started on scientific notation. Have a great day. OUT spells out.